Now that we've gotten under our belts some of the commands in assembly, and we know that if statements are not natively supported but can be done using bit tests, I want to introduce a little bit more about how to construct if statements within assembly. So let's go ahead and start with an exercise that's designed to put together a lot of the things that we've learned so far. And so here is what we are going to charge you with in this video. First, we want to create a short program. We're going to use labels, logical operations, bit tests, and bit sets, gotos, and a bit of our knowledge about the status register to use an output on port B, that is, we're going to use bit 0, to indicate if the input on port A, bit 3, is high or low. If port A, bit 3, is high, then we're going to set port B, bit 0 to 1, otherwise we're going to clear it to 0. So effectively, we're just checking to see what's the value of one of our inputs, and correspondingly, we're going to either set or clear one of our outputs here. So in order to do this, we need to think about what actually has to happen. And one way we can visualize that is with a flowchart here. So remember the diamond operator, that's the decision. So we're asking ourselves, is port A bit 3, also known as RA3, is that equal to 1? If it is, then we're going to set RB0 equal to 1, port B bit 0 equal to 1. If it's not, then we're going to set port B bit 0 equal to 0. And then presumably our code's going to do more things than just this, so we're going to rejoin after we do that and go on to whatever other code we have to execute. So we have this one if statement. We want to figure out how to write that in assembly. Unfortunately, assembly doesn't natively give us an if statement. It'd be really nice if it did, but we're going to have to go about this in a little bit more roundabout way. So what's the first thing we need to do? Can we go ahead and get on into the bit tests? No. We have to do a little bit of housekeeping first. First of all, we have to establish which of our pins are inputs and which of our pins are outputs, and we need to go ahead and configure them accordingly. So we're going to use our tris A. Remember, that is short for tri-state A. That's going to set up port A as either inputs or outputs. And in particular, we are interested in bit 3, and we want to make bit 3 of port A an input. Likewise, we're going to use tris B to make port B bit 0 an output. So we can go ahead and set or clear things. Hopefully you remember, to make something an input, you set it to 1. To make it an output, you clear it to 0. So before we can even do that, though, we have to recognize which bank our tris registers are accessible through. And so our tris registers happen to be accessible through bank 1. Normally, if we don't change banks at all, we're going to start out in bank 0. And so we need to go ahead and switch over to bank 1. So we've got to remember what we learned in the previous lecture about how to switch over to bank 1. So here's some code that we can use to do just that. These two lines of code will put us into bank 1. Remember, the RP1 bit and RP0 bit in the status register will put us into the different banks. And so in this case, if we clear RP1 and set RP0, that's putting a 0, 1 in that combination of 2 bits. That's going to put us into bank 1, which is where we need to be to access the tris register. Then what we're going to do is we're going to do a bit set on bit 3 of tris A. And setting that bit makes bit 3 of port A an input for us so that we can read in the values that are coming in. And then we're also in the same bank to access tris B, and what we want to do there is we want to clear bit 0 of the tris B register. That's going to set up our output there, so that in port B bit 0 we now have an output that can indicate what value we've got coming in on our input. So then after we do that, we want to go ahead and read in what's going on port A. Particularly, we are interested in bit 3 of port A. And we can do that a few different ways. I'm going to first start out with a little bit longer way to go about doing that. And I'm really going to do that just so I can illustrate a little bit more about what you can do to utilize the status register. So let's go ahead and see the long way, and then towards the end we're going to clean this up a little bit and go with a little bit of a shortcut. So we have to go, first of all, back into bank 0, because that's where we access port A and port B. So remember, right now, if we've just executed the code we developed on the previous slide, we were in bank 1, so we got to go back down to bank 0, so we'll have to change a couple of our bits in the status register there. And then one of the things we can do to isolate one bit in particular is to use what's called a bit mask. And what that means is we're going to create a logical value. We can put that into our W register, and we're going to establish ones in the place of where our bit of interest is located, and we're going to put zeros everywhere else. And then we're going to use a logical AND to AND those ones with our register that we're looking at, and then because we're ANDing zeros in all the other places, all the other bits that we don't care about will be masked onto zero. So we'll see how that works in just a moment. So here's our first two lines. We're going to switch back down to bank 0. So we're going to go ahead and clear out RP1 and RP0. You don't necessarily need this first line here because you were just in bank 1. We already had RP1 was 0 before. But just to be complete here, to make sure that I'm showcasing what we're doing with both of those bits, I've cleared both of them, so I'm now back down into bank 0. Then what I'm going to do is I'm going to set up my bit mask. And so I'm moving a literal value, that is a constant value, and I'm using hexadecimal 8 here. And remember, this is one of several ways that we can represent hexadecimal. I could have put 08H in there. I chose to put 0x08. And so if we look at that in binary, what that's going to do is that's going to put 0000 in my upper nibble, and in my lower nibble I'm going to have 1000. That's going to put a 1 in the same place in W as the bit I'm interested in is located in port A. So remember, in port A I'm interested in bit 3, which happens to be this location here. So remember, our bits are numbered starting at bit 0, 1, 2, and 3. So we're going to put a 1 in the W register, only in bit 3, zeros everywhere else. Then what we're going to do is we're going to perform a logical AND operation. Effectively what that does is it takes every bit that is in W and effectively puts it through a single AND gate. You can think about it going through an AND gate and looking at that what the results are. And we're ANDing specifically with port A. So if we AND 0 with anything in port A, we're going to get a 0, and that's going to happen everywhere else. And then right here, what's going to happen? Well, we're ANDing a 1 in W with whatever happened to be in port A bit 3, and if that was a 1, the result of that AND operation is going to be a 1. If that was a 0, the result of that AND operation is going to be 0. But we know all 7 of the other bits are going to be 0. And this comma 0 here says, put the result of that back into the W register. So remember, we have the option. We could put that into comma 1, which would put it into port A itself, or we could put it into the W register. In this case, we don't want to change what's happening on port A. Port A is an input. We can't change it. So what we want to do is just do a little bit of a check to see what's going on there, and so we want the result to go into the W register. So after we do this AND operation, the contents of the W register will no longer be this mask that we set up on the previous line. It's now going to either be the same as the mask, if that particular bit in port A was a 1, or if that particular bit was a 0, then the value in the W register will go to 0. And so then what we want to do is look at the value that shows up in the W register. So these are our two options that we just talked about. After that ANDing operation, you're going to have one of these two values. If the bit you're looking at, that is port A bit 3, was a 1, you're going to get this value here. If it was a 0, you're going to get this value right here. And if it did happen to be a 0, then the Z bit in the status register would be set because the result of a logical operation was a 0. And so now what we can do is a bit test on the Z bit, that is testing the status register and the Z bit to see if the result of that logical operation was 0 or it was not. We know if the result went to 0, that means that RA3 was in fact a 0. If it did not go to 0, then that means that RA3 was a 1. And so then we can use gotos to branch out to determine whether we're going to turn on port B bit 0 or we're going to turn off port B bit 0. So let's go ahead and take a look at that. So here's what we're going to do. We're going to do a bit test, and we're going to skip if it's clear. I could do a skip if set. That's fine too. But for this code right here, I'm going to do a skip if clear. So remember what that does is it tests a particular bit, and if it is a 0, it's going to skip over the next line of code. If it's not a 0, it's just going to flow right on through. So I want to check to see if my Z bit in status is a 1 or is not a 1. And it's a little bit confusing to think about that, because if the result of the operation was a 0, then the value of the Z bit will be a 1. Notice what we did here. You can say status comma Z, so a lot of the bits have a special name inside of the registers. You can use that name, or you could use the bit number here. You could put a particular number, which if you look back to the previous slides, you know which number corresponds to the Z bit. But I'm just going to use Z so I don't confuse myself and don't remember which number in the status register happened to be the Z bit. And so what I want to do is, if it is clear, then I'm going to skip, and I'm going to go down here to RA3 is high. So what that means is, if it was clear, that means the result is not 0 in here, and that must mean that RA3 was a 1. So I'm going to come down here to this goto statement, and that goto statement is going to take me on down to this label RA3 is high. And I haven't put any code there yet, I'm just putting that as a placeholder. Otherwise, if I do this bit test here and it was set, I find out that the result of the operation is a 1 in the Z bit, indicating that I got a 0 out of my ANDing or my masking, then I'm going to go to RA3 is low. That's going to come down here. And so this is effectively the decision operation. I'm making a decision about what happened when I did that mask. I'm making a decision based on what the value of RA3 was. And if it was high, let me go ahead and fill in this code here, then I'm going to turn on or set port B bit 0. So I'm doing a bit set F port B bit 0. So these over here are just labels. You could call them whatever you want. And so we're using those labels down here in our goto. And otherwise, you may have guessed what we're going to want to do is bit clear F port B bit 0. So now the question is, am I done? I've done a bit test after I masked. I've figured out whether it's high or it's low. And then if it was high, I'm going to go ahead and turn on port B bit 0. If it was not, I'm going to clear port B bit 0. Well, the problem with this is that, remember, code typically just flows one line to the next to the next. So if I leave these lines right on top of each other like this, let's suppose RA3 was high. And so I come here, I do this bit test, I skip over this line, RA3 is now high, and I flow down to this line of code right here. If I go here and then I just let the program counter increment normally to the very next line, what happens immediately? Now I set it for a very brief period of time, and now all of a sudden I'm clearing it back again. So what we want to do is actually, after we go ahead and set it here, we want to be able to skip over this next line of code and move on to the next things we've got to do. So we're going to put a little go to rejoin, and then we're going to skip on over, and here's where we're going to go to this rejoin portion. This is just another label, and then whatever the rest of your code is going to go there. I've likewise done the same thing here. If RA3 is low, I'm going to go to rejoin. I don't really need this here, because obviously if I just flowed on through, I would go to this next line of code, but I'm just putting that there so I can be explicitly clear about where I want to go to after I get out of my if statement. So if we put all of this together, here's what it looks like, and let's review what happened. We first of all have to configure our ports as inputs and outputs, and in order to do that we had to be in bank 1. So these first two lines put us into bank 1. Then we come on down here and we're accessing tris A in order to make port A bit 3 an input. We're accessing tris B in order to make port B bit 0 an output. Then we're going on down here and we're switching back to bank 0. So for simplicity, I've just put in the bit clear for RP0, and I'm trusting that that RP1 just stayed at the 0 that it already was up above, because I don't need that there. Here's where I'm putting in my bit mask. Remember, that has a 1 in exactly the spot where we are interested in the bit in port A. And now we're performing our masking using this AND operation. All the other bits of port A get siphoned off by this mask operation, and we isolate bit 3. That is the bit that we are most interested in. And then we're doing this bit test on the Z bit to figure out whether the result of that masking was a 1 or was a 0. And we're going to go to the corresponding places down here and go to our rejoin. So after long last, we now have some code that should do this for us. The question is, can we simplify this a little bit? This seems a little bit cumbersome, and the answer, of course, is yes. And we would do that using a direct bit test on port A bit 3. I just did this long roundabout way so you could see what happens with the status register. So what we can actually do is we can go back to this code here, and instead of doing this masking and then checking to see if the status register was, that bit Z of the status register was a 1 or a 0, what we can do is just do a direct bit test. So we can replace this line of code here with the mask being put in with a literal value, the ANDing, and this bit test of the status register with just a single line of code. We can do a bit test on port A bit 3. And here we're going to do a bit test F skipping if set. So if port A bit 3 is high, we're going to go down to here. If it's not, we're not going to skip, and we'll just fall down to here. The rest of the code stays the same. So here's one way to do a simple if statement. We can also clean up some of our other code. So in this case, we don't need the RA3 is high because that flows right on down to the next line. We can also clean up and take away the last go to rejoin. So here we've simplified our code. I hope you will continue on to the next video.